In the second part of this chapter, we're going to move on and start talking about thinking and thought. And it's a nice transition moving from language to thought because in a lot of ways, thinking is sort of like internalized communication, where you've turned that language and the production of speech and things like that internally. Though I suppose fairly recently there was a popular discussion about the fact that a lot of people don't have that internal monologue, that inner voice running through their head. So conceptualizing thought as a running monologue isn't necessarily the complete picture. But maybe it helps you to think about thinking. So you can hold that in your mind if it helps. But as we start talking about how we think and conceptualize and get into reasoning and problem solving and things like that, we're going to start laying some groundwork for what it is that we're talking about. So first off, let's start with different categories of thought. We have propositional, imaginal, and motoric thought. So let's start with propositional. So propositional thought is going to be expressing statements, a proposition. Things like, I'm hungry, it's almost time for dinner, it's cold here. Those are all propositions, those are all statements. And so those are the kinds of things that you can think inside your head. You can also have imaginal thoughts, which are going to consist of images that we can see, hear, or feel in our mind. If I tell you to imagine being on a warm, sunny beach, you can see and hear and feel what that might be like using imaginal thought. And for our last category, the motoric thought, that's going to relate to how we mentally represent motor movements. So if you think about throwing a baseball, you're using motoric thought to think about how you would move your arm to actually complete that action. So these three types of thought are pretty good broad categories for ways that we can think about things in general. And the next little bit is going to describe a situation where they actually harnessed someone's thought to accomplish something in the physical world. And this is going to be a good way of kind of crossing that threshold and showing that thought isn't just something abstract and in our heads. Thought also corresponds to changes in our brain. Our neurons are firing in very specific patterns as we think about very specific things. So the same way that when you look at written language, your occipital lobe, that visual cortex in your brain, is going to activate because you're looking at something. When we're thinking different things, you're going to activate different parts of the brain. And so in this example from the textbook, we can look at someone, this someone being Tristan Lundemo, this guy here on the slide. And basically, a bunch of researchers attached a collection of electrodes to his scalp so that they could monitor his brain activity. So electrodes would just be receptors stuck on the surface of his head to pick up changes in electrical signals coming from the neurons in his brain. And these researchers could hook him up to a computer, and the computer could analyze different patterns, different intensities of electrical signals in different parts of the brain, and start using that information to figure out what he's thinking. And in this case, it's something very basic. They calibrated the computer to know when he was thinking in a different direction. So if he was told to think up, then the computer would record his brain patterns as the idea of up or down or left or right. And they use this information to allow him to control the movement of a cursor on a video screen. So just by using thought and these electrodes on his scalp, he could cause the cursor to move up on the screen or down, left or right, just by thought process. And this is very interesting because This would allow people who have no ability to move or speak or interact with the physical world in any way, say someone who had suffered damage after a car crash and couldn't move their arms or legs anymore. This kind of technology could allow them to control a cursor on a screen and maybe point at words or letters to start communicating with people. So this kind of research is that bridging the gap from the things inside our head and allowing us to bring it outside as well. All right, enough about cool experiments with using the power of the brain. Let's start talking about some of the terms that we're going to be using as we talk about concepts, or as we talk about thought, and specifically concepts and propositions. Now, we've already mentioned propositions when we talked about propositional thought, where propositions are going to be statements that are expressing an idea. And propositions are actually made up of concepts that are combined or linked together in a particular way. So what are concepts? Concepts are just our basic unit of semantic memory. They're going to be kind of like phrases. So if we jump to this example here, concepts are building blocks for how we think and reason about things. So we could have concepts of students. So the idea of a student, or the concept of intelligent people. And a proposition is going to link those two concepts together. So the proposition could be that students are intelligent people. So we've used a verb here to link these two concepts. So we've linked students and intelligent people by saying that students are also intelligent people. And that's how concepts and propositions work together. Now, when we're trying to define these concepts, a lot of times concepts end up defined by what are called prototypes. And prototypes are going to be our most elementary or most basic method of forming those concepts. A prototype will consist of the most typical or familiar members of a category or a class, the members of that concept. So we can use the example of, think of these questions. Is an eagle a bird? Is a penguin a bird? Is a bat a bird? And in this case, the answer to the first question, is an eagle a bird, is a quick yes. Eagles fit our prototype of what a bird is. An eagle flies, it has wings, it's a bird. For a penguin, you might have to think about it a little bit longer because, yes, penguins have wings, but now they don't fly. And similarly with a bat, bats have wings and bats fly, but they're also mammals, so they're not quite birds. So the last two don't fit our prototype of what a bird is. So it's a little bit harder to classify. So prototypes are based on similarities. So for the prototype of birds, it's flying, having feathers, laying eggs, however you define birds. And a lot of these categories, these prototypes, help form children's early concepts. So children will look at a lion and a tiger and they will say that it's a cat because that's the prototype that they're using. Those are types of cats, so that's how they've classified it. And if we come back to our propositions, to our statements, we can run into this interesting conundrum where propositions can be worded in different ways such that they are logically equivalent, but they aren't necessarily psychologically equivalent. So for example, we can use this example listed at the bottom. You can talk about a 60% survival rate, and logically, a 60% survival rate is equivalent to a 40% fatal outcome. But depending on which proposition you make, which statement you're making, we can interpret it very, very differently. So if someone's talking about a 60% survival rate, you focus on that survival rate. So that could influence your decision. If you're deciding to undergo a medical procedure and it's worded as having a 60% survival rate, you might be more likely to agree to this procedure. Whereas if someone is talking about a 40% fatal outcome, that's focusing on that fatal outcome. And that could influence your decision because now that seems too risky. Maybe you won't go ahead with that procedure. So even though both of these statements, both of these propositions are logically equivalent, they don't have the same psychological value. Our evaluation changes depending on how we weight those statements. Now we can move from our basic building blocks of thought and thinking, and we're going to start talking about reasoning. Reasoning here being sort of the ability to think logically, to reason your way around a situation. We can use reasoning as a method of avoiding just trial and error. So instead of, if you encounter a problem, instead of trying every possible solution to it, maybe you would sit for a moment and consider which solution might be best. If you are sitting and considering, then you're using your reasoning ability. And we can talk about two types of reasoning, deductive reasoning and inductive reasoning. For deductive reasoning, you're going to reason using general principles to come to some kind of conclusion. This is basically a top-down process. So you're using principles and ideas, information that you already know, to try and logic your way to a conclusion. And this is a very useful process when trying to form hypotheses. If you're considering a problem in the framework of what we already know from the research in that area, you could come up with a logical hypothesis for your research. If you know that children tend to learn language better at a younger age, then your hypothesis might be that children who are introduced to a second or a third language will perform better in that language the younger they're exposed to it, to go along with our earlier part of this chapter. But you can use that deductive reasoning to come up with a logical conclusion. And as students, you're going to encounter a lot of this deductive reasoning. This is where a lot of mathematics comes in. So mathematics and even logic as a field, which of course overlaps with programming, which uses logic. So you could use things like if-then statements. So you could make the statement that if all humans are mortal, then this person I've encountered, who is also human, therefore must also be mortal. And of course, to contrast this, we can talk about inductive reasoning, which is going to be more of our bottom-up processing. You start with very specific facts and try and build them together. You start to construct them to develop a more general principle. So you're putting together the individual elements to build up to a larger whole. So inductive and deductive reasoning are kind of like our top-down and bottom-up processing, which, of course, for those who are visual learners, we can have this interpretation where deductive reasoning starts with our general principles, these assumptions of different situations, and you can fit them to make a conclusion regarding this specific instance. With inductive reasoning, you're going to start with your individual facts, your little pieces of information. You can evaluate and combine those facts to formulate a general principle. So starting with the units and building a whole versus starting with larger principles and applying them to a particular situation. Now that we've talked a little bit about reasoning and methods of reasoning, we can talk about some common stumbling blocks or problems that can get in the way of reasoning. The first of these is distraction by irrelevant information. So this is very, very common if you're given math problems. So if you've ever been in a class and they tell you that, there's a train on the track and it's driving north at this many kilometers an hour and it left at this time of day. And then there's another train on a different track traveling in a different direction. And they give you all of this extra information. So in those situations, you have to take a moment and evaluate which pieces of information are actually useful. And if you fail to focus on relevant information, if you focus on things that are there as distractors or things that don't matter, then it can impede your ability to reason. The textbook uses a really interesting example here, where they present you with this logic problem. And they tell you that you have a drawer of socks, and in that drawer you have 19 black socks and 13 blue socks. And they say, how many socks do you have to pull out of the drawer before you have a matching pair of socks? And most people approaching this question will start thinking about the mathematics behind it, the probability behind it. Okay, so there's 19 of one color and there's 13 of the other, and you have a 50-50 chance of drawing each. And when you actually see the solution for this question, the answer is a lot simpler than what you would have thought from the information they gave you. Regardless of the number of each type of sock, we only care that there's 2 colors to choose from. And no matter what happens, you would only have to choose 3 socks. After choosing 3, you are guaranteed to have at least 2 of one of those colors. So the fact that there's 13 versus 19, or whatever number they give you, is irrelevant. And it complicated things. So your reasoning got complicated by things that weren't necessarily important. Another stumbling block with reasoning is the belief bias. And this comes back to the idea that humans have biases. And people have this tendency to abandon logical rules, those rules of reasoning, in favor of our personal beliefs. So you can confuse factual correctness with logical correctness. And again, the textbook has a great example where they use this logical argument. And we're focusing on the logic here. So the first statement is, all things that are smoked are good for one's health. The second statement is, cigarettes are smoked. So our conclusion from this logic is that since cigarettes are smoked and all things that are smoked are good for one's health, cigarettes are therefore good for one's health. And when students were asked if they agree with this statement, if this is a logical conclusion, a lot of people would say no, because we know from research that cigarettes are bad for your health, so people disagreed with this statement. But they've confused the idea of factual correctness with logical correctness. In this situation, using those logical statements, that is a valid conclusion to draw, just from those statements. But if we are looking at factual correctness and what is correct in the real world, then yes, that's an incorrect statement, but that's not what people were asked. So this belief bias shows that we can confuse facts and logic, especially if they stand at opposition to each other. And our last reasoning stumbling block is going to be emotions and framing. And so when we talk about framing, we're talking about the idea that the same kind of information, the same problem, the same options, can be structured and presented in different ways. Kind of like when I was talking about framing it as a 60% survival rate versus a 40% failure rate. That's a difference in framing. And people can have emotional responses that differ based on that framing. So if you base your conclusion on how that wording is framed, it can affect your reasoning. So if you're okay with a 60% survival rate, but you're not okay with a 40% 40% fatality rate, then you have a flaw in your reasoning, because both should be equivalent. Both are logically equivalent. And these just come back to problems with humans with our biases and our problems with emotional attachment.